Hi everybody, this is Jim Corkins, and we are in this section where we're in 1.3 section, we're reviewing vectors, trigonometry, and the addition of vectors in 2 dimensions, okay? So you've already done addition of vectors in 1 dimension up here in week 3. So you've already done vector addition in 1 dimension up here in week 3, right in this tutorial. Now we're doing 2-dimensional vector addition. So this is going to help us with 2D motion, forces, and things like that. So in forces, we're going to be doing a lot of 2-dimensional trigonometry, 2-dimensional vector addition. And that's really going to carry on through into Physics 112, okay? And also 121 and 131 should you take that, okay? So again, what you do is you click on the tutorial, okay? Click on the download button, and then when you download it, that'll bring this up. Again, make sure you save it after you complete this assignment, all right? So let's talk about how to do this assignment, all right? So you've already done that. What I'm going to do is I'm going to go back to here, and I'm going to go out to my little area right here, 2-dimensional motion. And I've already got everything loaded onto a Microsoft Whiteboard, okay? So what this is, there's 2 pages to it. The first page has a bunch of problems where there's vectors written, and there's you have to write the sum of x direction and sum of y direction. And the next page is a part where they actually have it written where you have the sum of y direction equations, and you're supposed to draw the vectors from there. So let's do a little walkthrough on how to do this, okay? All right, so this is, I think, the 3rd tile, the 3rd pane. And I'm going to try to color code this because that just makes it easier for me. I'm going to color code this first one green. So the A vector is going to be a green vector. And this is the A1. Okay, and I'm just going to go ahead and write the A vector right there. The B vector, we're going to use blue. Oops, that is green. Let's change this to blue and baby blue. And that is pointing up and to the right. Up and to the left. And let's make the C vector, which is pointing down into the right, as that. So what I do is I lay down a coordinate system and I label the coordinate system. Okay, this is the first step in doing a force diagram. And anytime I'm working with vectors, I lay down this coordinate system. So I make a little dotted line and a dotted line going through this little dot, okay? And then I label it. Anything to the right is the positive x direction. Anything up is the positive y direction. Any vectors pointing to the left is the negative x direction. And any vectors pointing down, well, that's in the negative y direction. Going to need a little bit of space here. We call this negative y. And so laying down a coordinate system is important because it actually helps you do the addition of vectors and your trigonometry on this, okay? And again, I'm assuming that you have watched this 1.3.2 and 1.3.1 lectures, okay? All right, so this is going to be the area where we put our A stuff, and actually, I'm going to write that below. I'm going to say this is the area. Above this is where we're going to label our A vectors. Above this area is where we're going to label our B vectors. And above this area, we're going to label our C vectors. Okay? All right, here we go. So in the X direction, which way would you say that vector A is pointing? Left or right? Okay, well, that A vector is pointing to the left, so we're going to label it pointing in the negative, whoops, make that blue, green, it's pointing in the negative. So that's a negative A vector. That's pointing in the negative X direction. Okay? If anything vectors are pointing to the left, it's negative. Any vectors pointing to the right are positive. Now, the A vector is not pointing up or down, so it has no direction in the Y direction. So I just put a 0 there. Okay. Now to do the B vector, we're going to need a little bit of room. So I'm going to move that A off to the side here. Now this B vector, as you can see, it's got a B and it's got a 60 degrees labeled there. Okay. Since this vector is pointing diagonally, we have to break it up in accordance with our coordinate system, which is the Y direction and the X direction. Okay. And if you notice, this B vector is pointing up and somewhat to the left. And since they have an angle 60 degrees, what I do is, using this coordinate system, I imagine a little triangle going around this, encapsulating where you can see the B is now the hypotenuse of this triangle. And I make a little triangle going around such that I have a right triangle which encapsulates my 60 degrees. Now, from what you've learned from 1.3.1 lecture, which is the addition of vectors in 2 dimensions, that B vector, which is a hypotenuse, is also the resultant vector of 2 vectors that you've added together. Okay? And the question is how do you decide the directions of these 2 vectors? Well, you kind of decide them by describing that hypotenuse vector. If you notice, that hypotenuse vector is pointing up and to the left. Well, up would be the vertical part of that. Okay, so I'm going to make this solid, and I'm going to make this an upwards pointed vector. Okay, and that B vector is also, we describe this as pointing up and to the left, so it's also pointing to the left. Oops. So I'm going to make this part, which is on the horizontal, pointed to the left. So when you add the horizontal vector to the left and the up vector, the resultant, you start from here, you walk to the left, and you walk up. The result goes from start to finish, and that is the vector B. Now, what we have to do is decide on how to write the. We have a hypotenuse and we have an angle 60 degrees. So how do we write the upward vector and the horizontal vector in terms of that hypotenuse, B vector, and 60 degrees? Well, that's where your trigonometry comes into play. Okay? So what I'm going to do off to the side, actually I'm going to do it in blue, is I'm going to write sine of 60 degrees. Okay? And from what we've learned from trigonometry is SOHCAHTOA, right? Sine is equal to, the sine of theta is equal to opposite over hypotenuse. Okay. But if you notice, our hypotenuse is actually labeled B, and our theta is actually 60 degrees. Okay, so I'm going to replace, I maybe should have this already as theta. I'm going to replace theta with 60 degrees, and I'm going to replace the hypotenuse with the B vector. Now this side is the opposite side. So now what we have is the sine of 60 degrees. If we multiply B by both sides, it's going to be B sine of 60 degrees, and that is equal to the opposite side. All right. On the other side, here we go, we have cosine of theta, which is SOHCAHTOA, is equal to adjacent over hypotenuse. Well, our angle is not theta, it is 60 degrees, and our hypotenuse is labeled B. So this is cosine of 60 degrees, and that hypotenuse is B. In other words, the adjacent side is is equal to, so I multiply both sides by, I'm going to actually make this not capital A because that might be confusing. This is the side A. So this is the adjacent side. So the adjacent side, this is the opposite side. So we multiply both sides by b. So this is going to be b cosine of 60 degrees. Okay, so we have those two things. So what we have is a way to write the opposite side in terms of the hypotenuse and sine of 60 degrees. And another way of writing the adjacent side, which is in terms of the hypotenuse and cosine of 60 degrees. One thing I know about trigonometry is the side that is physically touching the angle 60 degrees, which is right there, which I'm going to make black. That is the cosine side. That is the adjacent side. So this part right here, this angle, this side that's pointing to the left, is going to be b cosine 60 degrees, and it's pointing to the left. So it's pointing in the negative x direction. The side opposite the angle 60 degrees, so happens to be the vertical side here this time. So that is going to be b sine of 60 degrees, and it's pointing up. Okay, so in the x direction, we have a vector labeled negative b cosine 60 degrees. And in the y direction, that b vector is pointing up, and it's b sine of 60 degrees. Okay? Let's do the c vector. Okay, now that c vector, again, we're going to have to make a little triangle for our c vector. And if you can imagine, the coordinate system kind of helps us build this triangle. So that c vector is a hypotenuse, and here's a little triangle. We're making a little right triangle that encapsulates that angle 40 degrees right there. Okay. Now, the format that we're going to think of this is that the vectors, if you break a hypotenuse that is labeled, it'll always be hypotenuse sine of theta or hypotenuse cosine of theta. Okay, so in this case, this c vector, again, we're going to do addition of vectors, is pointing down and to the right. So this horizontal part of this vector has got to be the rightward part of that vector addition, and the downward part is the vertical part. So when you add that downward vector to the right vector, you get a hypotenuse or resultant vector that looks like this. In other words, if you started here, you walk down, and then you walk to the right, you finished here. So that is, you always do the resultant vector from start to finish, pointing down to the right. Okay. Now let's start labeling these vectors. Okay, so now it always goes, as from what we learned up here, it always goes hypotenuse sine of theta is associated with the opposite side, and hypotenuse cosine of theta is related to the adjacent side. Now, can you spot the adjacent side, the adjacent to the angle 40 degrees? Okay, well, if you look at which side physically touches the 40 degrees, you can see this vertical side does. Okay, and again, we're going to write it in format. It goes hypotenuse cosine of 40 degrees. That is this side, and is pointing down. And our hypotenuse is labeled C. So this side right here is hypotenuse cosine 40 degrees, or the C vector cosine 40 degrees pointed down. This side, which is opposite the angle 40 degrees, is pointed to the right, and it's the hypotenuse sine of 40 degrees. So you don't have to write this every time, okay? You can just go right to thinking about vectors this way. Well, this rightward pointed vector is pointed to the right, so it's going to be c sine of 40 degrees. And the other one is pointing down, the vertical part, and that is c cosine 40 degrees. Okay? Now, for some reason, a lot of us always think about the horizontal vector is always cosine. That is not true. It has to do with the angle. The side opposite the angle can sometimes be cosine. The side opposite the angle 40 degrees is always sine of it'll be hypotenuse sine of 40 degrees. The side that is adjacent to the angle is always going to be cosine. So in this case, since the angle 60 degrees is touching the horizontal, that happens to be cosine. But in this case, since the 40 degrees is touching the vertical vector, it is going to be c cosine 40 degrees. Okay? So that's how to do the first page of 1.3.2. Okay? The second page here, now we're supposed to actually create the vectors from this. Okay? So I'm going to show you how to do that. Again, we're going to start off by laying down a coordinate system. And again, there's a lot of ways of doing this. You don't have to always do it my way. Some of you are better than trigonometry than I am. But this part is pointing x, this is pointing y, negative x, and negative y. I lay down coordinate systems whenever I'm working with vectors. Okay? So there's a lot of ways to doing this one. Okay? And again, what we're going to use is we're going to use the a, b, and c here. Okay? So the a vector we said is green. So this describes the a vector. This describes the b vector. And this part describes the c vector. Okay? So let's look at the a vector first. Go right in order. Okay? Now, if you look at the a vector, don't get overwhelmed. This is just a name. So what I do is I kind of ignore this sine of 35 degrees for a moment. If you notice, this a vector is positive in the x direction and is positive in the y direction, right? So that means that a vector, a sine of 35 degrees, it's going to be pointed, starting from the dot, it's going to be pointed to the right. So I'm going to actually label this positive a, and that's sine of 35 degrees. Okay? Now the second vector, you could just add right to the very first vector. Since these are the addition of vectors, what you're going to do is I'm going to add that upward vector, since it's positive, and that's the a cosine of 35 degrees. And since I started right here, I walked to the right and then I walked up, then I'm ending my trip right here. The resultant vector is going to point from start to finish, and this is the a vector. Okay? All right. And there's a lot of ways to do this, but I'm just trying to be simple about how I do things. Now we have to decide. So once we've labeled our a vector, now we have to decide the angle 35 degrees. Okay, so this is a right triangle, so we know this is 90 degrees, but we have this choice, this vector right here, this side, or this side, as our, to decide which one of those is 35 degrees. So how do you decide which one of those is 35 degrees? Well, what you could do is look for cosine. The cosine side always touches the 35 degrees. So this vector, the vertical vector, is actually the adjacent side. So that means this has to be 35 degrees. Okay? And that means this other side, right, this other angle right there is not 35 degrees. And so what I do is I just double check. If this is 35 degrees, then this side would have to be a sine of 35 degrees. Cool. It works. All right. There's another way of doing this, and I have to admit, a student showed me how to do it, and I thought it was great, so I'm going to steal it. Now, what you could do is do this an alternate way, and this is negative b cosine 75 degrees. In the x direction, negative b sine of 75 degrees. So in the x direction, we know this is going to be pointing to the left, but it's also going to be pointing down. So what I'm going to do is I'm going to describe a left and downward vector. So starting from here, I'm going to draw a vector pointing down and to the left. Okay? And we're going to draw it nice and big. And so that is the b vector. Okay? Now, just to verify that I did it, what I'm going to do is I'm going to make a little triangle. And then this vector plus this vector has to be equal to this vector, and it is. Okay, so that's another way of doing it. You could just go right to that. You don't have to construct the sides first. But I like constructing the sides first, and it does help me a little bit more with my trigonometry. So what I'm going to do is go back to that first method and say this is the sum of x. This b vector is pointing to the left. So I'm going to draw a vector to the left, and I'm going to label that negative b cosine 75 degrees. And then I'm going to add to that the vertical vector, which is pointing down, and that is negative b sine of 75 degrees. Again, if you started here, you walk to the left and you walk down, you finished here, the resultant vector goes from start to finish, and that is our b vector. Okay? Now we have to decide on the angle 75 degrees. This is the right triangle part, so the question is this going to be the angle, or is this going to be the angle? So which one is 75 degrees? Well, again, the cosine side is always adjacent to the angle, and so it physically touches it. So that means this corner right here has to be the 75 degrees, where this other corner is not. Cool, 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 cool. Very last part, C. C has no, it's actually 0 in the x direction, but it is pointing down in the y direction. So in this case, you just put a vector pointing down and label it C. Okay? And that is how to do 1.3.2 tutorial. Thank you.